Hi, welcome to the notes for today. Our notes are over direct and inverse variation. Our essential question is, how do we use the direct and inverse variation formulas to solve problems? So the first thing we need to do is start out with the definition. Direct variation is a mathematical relationship between two variables that can be expressed by an equation in which one variable is equal to a constant times the other. In other words, it can be written as y equals k times x to the n. And you'll notice that k is the constant of variation. So k is our multiplier. And n is the exponent if we have one. Most of the time we will not have one, but occasionally you do. We will use this formula if we need to find the constant of variation, or the k number. If we don't need to know the k number, we're going to use a different formula. And one thing that I want you to notice about this formula is that there is not an extra number being added on to the end over here. So when I graph this, a direct variation problem must pass through 0, 0. If it does not, it is not a direct variation. And that will be important a little bit later on when you're looking at the graphs. So again, we will use this formula if we need to find out what k is. Otherwise, we are going to use this second formula. And this is the formula that we will use most often. And if you look at it, hopefully you recognize it as a proportion. So we've got x1 divided by y1 equals x2 divided by y2. We will use this formula when we know 3 of the 4 numbers, and all that we are looking for is the 4th number. So let's go ahead and pause if you need to. Otherwise, let's go ahead and look at the first example. So for our first example, we are looking at a problem where we have a direct variation. As you're reading through a problem, it's always important to note whether it's a direct variation or an inverse variation, which we'll talk about in a few minutes. So pay attention to that word, circle it, highlight it, but make sure you pay attention to whether it's a direct or an inverse variation, because that's going to determine what formula you use. So y is varying directly with x. It says if y is equal to -3 when x is 6, we want to determine y when x is 18. So I'm not trying to find the constant of variation, I'm just trying to determine the 4th number. So we're going to use this formula here. So the first thing I'm going to do is I'm going to label my x's and y's as x1, y1, x2, y2. So the first set of numbers I'm going to call y1 and x1. And then the second set, the ones that are being compared to each other the second time, I'm going to call y2 and x2. So it appears we are looking for y2. So now I'm going to go plug them into my formula up here. So it says take x1, which is 6, put it over y1, which is -3. That's going to be equal to x2, 18, over y2, which we don't know, so we'll leave y in the blank. Now, because this is a proportion, I'm now going to solve it by cross-multiplying and dividing. So I'm going to cross-multiply. -3 times 18, I get -54. 6 times y2, I get 6 y2. And now I'm going to get y2 by itself, so I'm going to divide both sides by 6. And when I do that, I'm going to get my answer of -9 for y2. Let's go ahead and pause. copy your notes and then come back and we'll talk about inverse variation. Alright, our second definition is for inverse variation. Inverse variation is a mathematical relationship between two variables which can be expressed by an equation in which the product of two variables is equal to a constant. So this time I'm multiplying x times y and I'm getting the constant k. Again, we've still got our little exponent here on x if we need it. Most of the time we will not have one. But I can also take this same equation, and if I put it in terms of y, when I solve for y, I'm dividing both sides by x to the n. I will get the more familiar form of the equation, which is y equals k divided by x to the n. And this is the format that you'll see when it's solved for y. Again, k is your constant of variation, and n is the exponent if you have one. We will only use this formula if we need to determine the constant of variation. Today we're going to be concentrating on finding the fourth term. So once again, like with the direct variation, we have another formula which we will use more often, and so this is the one that I want you to see. This formula looks very similar to the direct variation formula, except there's one difference. This time we have x1 over y2 and x2 over y1. So I want you to notice that the y1 and the y2 got switched, because remember we're doing an inverse variation on this one, and so inverse, one of the meanings behind it is that you switch them. So x1 over y2, x2 over y1. So let's go ahead and do an example with this, and then you'll be able to practice some problems on your own. And our example says y varies indirectly with x. If y is 30 when x is 12, determine x when y is negative 10. So let's go ahead and set this problem up and solve it. So the first thing I'm going to do is I'm going to go circle that word. Because I'm using indirect variation, I need to use this second formula, which is x1 over y2 equals x2 over y1. Now I'm going to label my parts. This is my y1 and my x1. This is my x2 and my y2. Once I've gotten everything labeled, I'm going to go ahead and plug them in. My x1 is 12, so it goes on top. My y2 is negative 10. Just follow the formula. x2, I don't know, so I'm going to leave x2 in that little blank. And y2 is negative 10. We already put that one. The next thing I'm looking for is y1, which is 30. So again, I'm just plugging each thing in where it goes in the formula. You need to pre-label it so that you can plug them in accurately. Okay, once I've plugged them in, now we're just going to follow the rules for solving a proportion, which is we're going to cross multiply. $30 times 12 is 360. Negative 10 times x2 is negative 10x2. Now we're going to divide by negative 10 on both sides. And we get x sub 2 is equal to negative 36. And that is how you solve an inverse variation problem. So go ahead and pause, finish copying your notes, and then begin working on your direct and inverse variation problems. Have a good day. Bye-bye.